to take some questions. So yeah, so what we learned the first 2 days is regarding about data installation and the R installation, then the basic some operators, and then some logical operators also we have done. Then we have also learned how to import the data or export the data from some outer source. And the last day mainly we focused on various type of data frames, data cleaning, then some different type of data manipulation, etc. We have started. And then there were some few queries regarding some if we have some big data, how to handle with those datas with some data clinic and all those. So basically, these are the some of the points we have started last day, and I have also given some query, and we have also done some plotting also, if I could remember. So yeah, so this all are we have started, and now we'll see if there any issue, and we'll also see if what I have given some questions, 4 or 5 questions I have guessed, or maximum 10 I have given. So if you feel any issue, you can raise your hand or you can mention. Yeah, you can start, Darshana. Darshana, you can unmute, then you can mention your issue. Uh, maybe see solution. Sanhita, yes, you can start.
Sir, actually, in the previous session, it
Mhm.
was shown how to plot the graph in case of data frame. So in question 7, it was a vector. So how to do it in case of a vector, like how to plot the graph?
Okay, it was, I think, box plot or something was there.
Yes, yes, box plot.
Yeah. Okay. Any more query? There is a question regarding
And
any of
also in
these.
question 10, I guess the highest and for a bar graph, the question was to find out the order bus from highest to lowest. In
Yeah,
question,
we have to make the chart, bar chart from highest to lowest. So now we have how to walk with six. Okay, I think it is easy only. It means gender wise, we have to calculate the average age and maximum score, I think. Okay. Okay. I think so. Question 6, then question 10, and which one last? The vector one.
yes, question 7.
That's it. Okay. Question 6, 7, and 10. Okay. I'll try to solve those. I think we should share the screen. Yeah. I hope the screen is visible to everyone. Yeah. Okay. So you are asking about question 6. Question 6 is we have to create 3 variables: gender, age, and score. Then we have for each gender, we have to calculate the average age and maximum score. Okay. Okay. So just starting a new script. So for that, we have to create the library TPLYR because we have to grouping. We are doing the group uh, analysis. So by group, we have to show. So for that, first you have to write the library, which library you need, that is TPLYR, which I already have talked about. So first you have to all the library, then you have to suppose gender one variable was that, and then we have to write the water information that is still there. Maybe I can copy from okay. This was the data I think. So we can run this one. So these three are the main variables we wanted: age, gender, and score. So for that, we have to first make the data frame we needed. So suppose DF, again I'm using data frame. It's DF, the file name. So don't be confused. So under the data frame, we have three variables: gender, then age, and then score. Okay. So uh, we created the data frame. There is three variable and five observation. You can see that uh, data also. Okay, this is the data we wanted to show. So now we want to show the summary. So for that, we have to use the summary function, which we have learned in the last season. So summaries. So for this, there is a trick. Means we want to see the gender wise. Okay, so we need to group it. So for that, we have to use a function called group by. So group, and if you write group, you will automatically get the group by option. Then you have to call that data frame, that file name df, then which you are want to group. You want to group by gender. So we have to mention the gender. Okay. So then the normal one, what we wanted, suppose we wanted average score. So average age, that is how we can found. We can found by calculating the mean of the age. So we will use the mean function. So mean of for calculating average age, we'll use the age variable, which will calculate from the age, average age. Average age will be calculated from the mean age. Okay. So, and then the maximum score we also wanted. So we'll giving the name as maximum score. Okay. So what to, how we'll get through the function maximum. Okay. And the variable name is score only, I think. I hope it will run. Yeah. So for that, we are just storing that with summarizing the data into a new file. Okay, to show, because directly it is not showing. So for that, we are just creating another one, another file, that is df1. I'm just giving a name as df1. So TF1, what we are doing, we are summarizing first by group. Group in the sense we have wanted gender wise, so we are doing by group by gender. The gender variable is under TF. Okay, so TF comma gender. Then we are normally calculating the average age, which is mean of age, or maximum score, that is maximum score. Okay, then we if we run that file, so we'll get the df1. So df1, how we can see df1, you can write also, like you can see by view also. Here, so from view also we can see gender wise what is the average age and what is the maximum score. Okay, this is the, this way you can see, and just copying that in your chat box for your convenience. Okay, I hope you can get now the question 6, uh, how we were making the group one. Okay, so then what we can see, the next one, the question 7, you want to know how we can do that. What was the question? So we want to draw a box plot and identify the outlier visually. Is this question 7? Someone wants to? Sorry, question 6. Sangeeta, you are asking for question 7?
Yes, sir.
Okay. So we want to draw, and you are asking if it is a vector, how we can do. The simple way, you just mention that vector, what vector is there. So first you have to just write the vector as it is. Okay. So you, if you run that one, you can store the data into X. Then the normal what you have learned the last class, how to plot through ggplot. So you have to use the ggplot function. So ggplot, you can use the, this is because directly we have used from data frame. If this data frame is not there, X can be used as a data frame only. Okay, so if you write data dot frame, okay, and in bracket if you mention X, then it will automatically take the X value. Okay, so then the normal aesthetic, among the aesthetic, what is your y? Y is your X only here. Okay, then you can give a color if you want. So I'm giving geom, we want to do the box plotting. So we are making box plot. So then I can feel, suppose I want to give some color, maybe sky blue. Okay, so then you can add some title if you want. So among the title, you can mention like box plot of X. Okay. So, and if you want the, what you want to see the values, because you want to see the outlier, so we can mention that we want to also see the values. So if you write y equal to values, it will give the values also. You can see now uh, this way. These are the values. In y-axis we are seeing, okay, this is the box plot, and we can see how the spreadness is there, and there is some values, maybe at this point this 100 is showing in this point because this is the outlier. Okay, is it fine?
Yes, sir.
Yeah, so that was there. And then question number 10 you were asking. So
Question number 10, second part.
17 seconds. Okay. Okay. Draw a bar chart, but order bars from highest to lowest. Okay. So for that also, we need to mention first store the data. Suppose where this was the data. City wise population is there. Maybe this one in million it is there. So we can mention some data frame. Suppose I'm giving data frame 2. So data dot frame. Okay. So what were the two variables are there? City is there, and then population is there. Okay. This was I want to give because there are two variables, so we have to make a data frame. Okay. Otherwise, we can't plot that one. So uh, that was there. So then we want to make the geo. Maybe we can do the bar also as well as column. Okay. So suppose bar I have already shown. So maybe I will show the column one so that it is similar to bar plot only. If you know the column, the concept of column and bar chart. Okay. I'm just for your information, I'm just showing how to make the column one so that it would be visually it will be good. Okay. So similar process for that. You just have to mention what are the y and what are the y, x and y. Okay. Suppose for x, we want to make the city-wise population. Okay. So how to make that? For that, you have to use the function d order. Okay. This will this will make the data among the highest to lowest. Okay. I just gave so that you can explore that one. Uh, for you because there can be many more questions like this. Okay. So and then we want to make that population minus y I am given. It is minus population means it is giving the highest to lowest. Okay. So for that I am given minus. Then this is the x wise. I want to arrange this one population wise. So I have ordered that one from plus to minus. So that's why I have given the minus one. If you give the plus one, it will be lowest to highest. Okay. So this is the concept of reordering. So then you can mention the what is the y? Y is your population only. Okay. So population, then you can mention the geom bar you can also do. And just for your this new type of visualization, I am giving the geom column. For geom column graph, you have to give geom col. Okay. Now you can give the field. It's filling the bar or the column. You can say if I am giving any color, you can keep. Suppose I'm giving dark green. Okay. Then you can mention some title also using this usual process title. So title maybe I can give population by city. Maybe I can add this and the order. Okay. So that you can give, and then you can also show the what is x and what is your y. So for that you have to mention x is your ct, x variable is your ct, because this lab is basically giving the level as you already seen last season. So I'm just mentioning the what are the level it will take. So I'm giving city and population. Okay, TF not found because we have not run the TF one. So first we have to run the TF. Okay, you can see this is city. It is giving the population wise. I have first reordered that. Mumbai has the highest population to Chennai that has the lowest population. That is, population is supposed 20 million, then it is around 17 or 6, and maybe 16 or 17 million. Then Kolkata is like 15 million. The Chennai is less than among maybe 13 or 12. Okay, so that's it. Is it fine? Okay, I'll give also the code so that the earlier code also. Okay. Yeah, you can check from the chat box. Okay, I hope that was the last question. Or any other query if you have, you can mention. Okay, okay, let me start. Maybe meanwhile, you can raise your queries later on also. So, last day, someone, I forgot his name, someone is mentioning about if you can use some big data, uh, means big data in the sense, if you have a real data, that if there is very much data uh, chunk in the data, means their garbage is very much, or outlier is there is very much outlier, or it's a big data, how we can proceed. Okay, so for that, I have uploaded some data. If you can quickly download from that one, I'm just sharing, showing for your convenience. Yeah, if you can see, there is some data I have already given in the this workshop day 3. Just giving this in your chat box as well, so that it would be easy for you to access. Or I'll also give into the WhatsApp group. How we setting the descending order. You can see that in I have used a function called reorder. Okay, for x axis we are giving the city wise. So for that we are using the x reorder function. Among the city I am reordering according to population, highest to lowest. That's why I'm given to -1. If you want lowest to highest, you would give city comma plus population. Okay, it will give the lowest to highest. You can check that code and see if you feel any issues there, you can raise. Okay. And meanwhile, please download this uh, day 3 data I have already given. I have already shared with you in the WhatsApp group also. Okay. So first we need this all data we needed today. Okay. Once again, I just need 2 minutes. I'm coming in 2 minutes. Please download those data meanwhile. Okay. Yeah, data is downloaded now. I hope it's downloaded. I'm start in the first we will use the large underscore outlier dot data. That data we need, we just want to show first what is the data. So yeah, so first we'll use the large outlier data. Okay, this is the, suppose this is the data of, suppose 500 people or 5,000 people, I think. Yeah. So their age is there, their score, some score is there, and they are from which city they are belonging. So their city is also there. Okay. So first we want to import this data. So the simple step, what we learn, we'll start with that. Okay. So maybe just what with the new one, new script I'm starting. I'm just saving this one as day 3. Okay. So this is a this clear button you can use in everywhere. So to clear the maybe console or plots if you want to clear, or maybe this one also if you want to clear the environment also. Suppose I'm clearing this one, it will automatically delete it, all the data. And this also you can clear the plots also. Okay. So we are starting the fresh one. So suppose I am giving a new uh, data we want to create, that is that CSV file. So we'll use the read CSV, read.csv function to import that data, that is large dot. I hope that was the name. If you're not sure, just you can copy that file name also. Okay. If we enter, there will be error message because we have not mentioned the path. Okay, so for that we have new, we have to mention the path, set the working directory. For that we have to copy our working directory. Okay, and then paste here. Then you have to give the back one, double back slice. Then okay, now if you run this one, still there is some issue maybe. Second. Okay, if you directly give this one into this, and also give, as I have mentioned also earlier, let me see, is it what? No, I think okay, you can copy the path. I hope this is only, sorry. So you just have to paste this. Okay, you have to properly keep that one, otherwise there will be some error also. Yeah, I hope it was some error in the directory. Okay, is there any query? Yeah, Hans Batra, you can unmute and mention what the issue is. So we have already, you can for earlier also you can set the directory, but there was maybe some directory issue, so I directly mentioned that path. Okay, and that file, that is large underscore outlier underscore data. Is the data is accessible to everyone? Can anyone confirm? Yeah. Okay, thanks. This is the data. You can see the data here also. Okay, I have named as TA. Then if you want to see, suppose there is four, five variable, age is there, school is there, gender is there, city is there. Okay, suppose we want to see the age one, if there is some outlier in that age. Okay, so for that I am just creating again storing that one in a new name, out, that is outlier underscore age. I'm just giving for my convenience. Okay, you can give it on your own. Okay, so suppose I am to see if the value of under the DA, that is age, uh, if age is more than 50. Okay, so what I have done, I have mentioned that variable I want to see df underscore age, among which df underscore should be more than 50. Okay, if we run, uh, we have created the values. These are the values which are more than 50. So if you want to check the length of it, that is called the function as length. We already have used that one also. So if you run length under the out underscore age, if you run that one, sorry, it is Newton. Yeah, it is run. One second. And I can view also. Yeah, these are the values uh, which are more than uh, 50s. Okay, you can see these values. Okay, similarly, there is a length is also should work. Maybe there is maybe some issue. Okay, I'll see this length one, but length one is also should work. Uh, we can see that in under the filter also, if we see among the data view. Okay, you can, if you click this one and go to the data view, there is an option also filter one. Okay, if you click that one, you can choose from here. You can make it any ascending or descending order. Suppose age I want to make change, so if we click this one, it will come as ascending order. Then if you double click this one, it will give the descending order. Okay, similarly you can do the score also. Okay, gender also, whatever the data is there, it will show the this was, means you can make it only ascending or descending order. Okay, so suppose we want to clean that now the data. Okay, so if you want to clean, means we want to clean and we want only the, if the age is less than 50, we don't need to manually do among the each age, each cell wise. We can directly create a function values. You can store the data into a new one. We are storing it into different name because we don't want to hamper the original data. We can make a sub data of it. Okay, so for that we are making the df clean, suppose where the age would be less than 50, suppose. So again, the df one we are using, that is the data frame name for us. So we want to make the data frame among the age variable only, and where the age is less than suppose 50 we want. Okay, so maybe this column, the name is different. That's why it is showing the error one. Data frame, yeah, and then you have to give the comma. Why we are giving it? So okay, so we have make from 5020 to 5000. Now, if you see the data, you can see all your age would be maximum of 49. Okay, all the data would be, the age would be less than 50. So if you don't know how to clean the data, so if you just give a if you can create a sub data or from that the data from that particular TF. So we are making only among the age who are age is less than 50. Then this you have to keep the comma, and then the rest means you have to close, because comma we are giving a means we are giving a means condition only. Okay, so for giving condition you have to, and then you have to give the comma, otherwise it won't run. It will say keep your means your condition is not fulfilled. Okay, for that you have to keep. Again, you can also see through box plot also. Means box plot is very easy to see the how if there is any outlier only. So suppose we are creating outlier function variable, that is, suppose we want to see the box plot one. Okay, box plot, suppose box plot dot, that is for using the box plot, it is box plot dot stats. Okay, and then you keep the that particular variable, you want to see the age one. Okay, and then you have to again mention you want to see the outlier. Okay, so if you run this one, there would be the outlier underscore age would be seen. The outlier will be seen. I hope the length one should work. Yes. No, I may be link. There is some issue. I'll see this link function. Okay. Ideally, it was working the other day. I'll see if there is some library some issue. Okay. Then okay, this way you can see the outlier if there is any outlier or not. For similarly, you can also do for score also. Okay, if the score, suppose you know the score should be something like less than something or more than something, you can also see because you want to know the means which score should not be there in your data, so you can filter out those data and save is in a new file name. Okay, so that your data should not be mixed. This way you can. Okay, so this is the one of the query last time it was there. So again, there is another one. It was there like if we have a large, I mean, data with a various not available, or there is some text in between in the number. Okay, how we can clean that one. Okay, so for that, we'll use another file, that is this I've given as dirty underscore large data set. Okay, I have created this data set. So we want to read that one. Let's read that one. Again, I'm giving df1. This one is for my convenience. So, okay, don't confuse me. I am giving the same data frame name for every file. It's up to you, whatever you want to give. So for that, we again we have to copy the path of that particular file. Anybody wants to share anything? Okay, so in length it is giving an output. Maybe there is some issue in my uh, console. Okay, so length should be given actually, because earlier the other day we were use that length function. Length function will give the number of outlier or number of box plot we are using. Outlier, it should be shown. Maybe there is some issue in my console only. If you are seeing that one, then it is fine. Okay. So now we can come to this one. Uh, you can run the second data set, that is this dirty underscore large underscore data set. Okay. So there is a trick in, I'll show the data set first. The earlier data set, I have done a wrong thing, but anybody has not mentioned that one. Can anyone inform me what I have done in the last reading, last CSV file? This is the this dirty underscore large data set. Okay, this we want to import. Okay, so for that, we are reading the given the path, then we have to mention something. Earlier I have missed that one. That is, we have to give the string as factors equals to false, because there is a factor variable was there, gender. Okay, that should be given false. Otherwise, all the other uh, numeric one would take as text. The in earlier data there was not that much issue because there is only one. Okay, but every time you are reading, if it is a factor variable or categorical variable is there, you should mention a string as factor equal to false. Also, header equals to true. Okay, here I am not giving, but you should give always while running your CSV file. So again, I have make this df1. I have read that one. This is the 7 variable data. If you see this one, yeah. So you can see there was 2 variable was there, which is text format. It was there, but you have to mention that this one is a categorical one. Okay, this one is a string we are taking. It is not it is as factor. It is not a normal string. Okay, you have to mention, otherwise there would be some issue. Means the data would not become as it is. Okay, so then you can check the str function. Again, there is some issue, I think. Let me once close that R and then open, otherwise maybe there was some issue. I hope str function would run for everyone. Maybe there is some issue for my setup. If you run the str one, I hope everyone is getting the desired result. As length was not coming for me, maybe for yours it is coming. You can similarly see the str function. Are everyone getting the str in bracket the df function? Can anybody confirm me?
Sir, ideally, what should we be looking for?
For what?
So, sir, I'm getting when I typed in str in brackets df, I'm getting data
Yeah,
frame
it will give the
33,000.
structure of the data. Means how the variable description it would give. Means characteristics, or it is some string or something. It will give.
Yes, sir, I think I got.
Yeah, if you're getting that one, your R is running finite. Let me again run those charts. Yeah, now it is working finally. Yeah. So you can see if you run that str1. I hope the length one would also work. Yes, now it is working. Okay, so fine. It's now if you run this, sometimes our there is some issue. Maybe backlog was there. That's why it was not coming. Okay, so if you run the str function, it will show the character means data frame wise. What are the variable types? Is it an integer? It is a character or something. But if you see, age is also showing character, score is also showing character, income is also showing character, but it should not be there. Okay, so there is some issue. So first you have to see the str function. It will give your data wise what should be the if you know your data means what variable denotes what, it should be numeric or text. So if you see there is a mismatch, then you have to check that data. Okay. So first, suppose we want to see the we want to make the numeric column, which are the numeric columns for our cases. Uh, suppose the DF among the DF. Suppose age, score, income. This should be numeric. Okay. First, we'll try for the age one. Suppose we want to we want to make the age one. So we are selecting the DF underscore age. Okay. So we want to make as numeric. All the values should be numeric. So we'll use the function as dot numeric. Okay. Then which variable we want? We want to that age variable. Okay. So it will turn all the non-numeric would be as NA. Means if there is a text, it will be turned into to NA. Okay. So if you run this one, okay, there will be some issue warning. NAs was introduced. Okay, so if there was some issue, they will convert into NAs. It's not available as it is. So if it is, I think it is changed now. Also another one. Suppose we also want to see the score one. Suppose we first check the score, how the score variable is there. I have just double click it. You can see the last columns. If you make it descending to ascending order, if you can see the values are there in the after 5 6 column. Okay, so 5 6 column.
Sir,
Yeah,
sir, how do I see this table that you were seeing right now? Like, I could see the out age last time, but now I can't see this table that you were
wait a
simultaneously
minute.
checking.
Also, you can, if you go to directly, you can see using the view command. View, capital view, it is there, capital view. Then if you mention the, suppose your DF, the data frame, view in bracket DF. Okay, if you run that command, this window will automatically come. Okay,
Yes, sir, got it. Got it.
yeah. So you can see from that one also. Otherwise, you can, there is a box. This box is there now in environment. If you click that one, it will also automatically come. Okay. So what I was saying, like the score variable, we want to filter, we want to see, suppose you pick the score one, you can see among the descending to ascending order, the values are there after maybe 6 7 uh, rows. The this sales, there is some text is also there. That's why it was showing the character one. Okay, so we want to remove this one as a not available. We don't want this data because this should not be there in the score one. Okay, so what we were doing, will make those into NAs. For that, we are mentioning the age one. Similarly, we can mention the score one. Okay. So for score, similarly, you can do the as numeric. Okay. Then you can mention that particular variable. And then if you run that one, similar warning would be there. And now if you see that data, and then if you double click that score, you can see yeah. Now I hope it will won't come. Yeah, but still there is some again some issues was there. Yes, for age variable you can see this were the error it was there. Unknown 20 999. This was the data. So for that we were just running that one. Then second. I hope I was mentioning this proper variable. Yeah, you can see there is some data is there, but that was wrongly mentioned. But now the text, what was there, it is now no now it is not there. Okay, this way you can convert those means text into some not available into turn into NS. Okay, I will also see this if the data is like this, we can also remove those data also. We can filter out those data which should not be there, which is outlier through the earlier process. Okay, so we can also see this converting the numeric as well. We can also detect the NS created during or this conversion. We can also see, suppose we can use the column sum, which we have already used that column sums. Okay, and if is NA is dot NA, sorry, and in bracket the DA function. Okay, you can see there is this many numbers of cells are there which are NA is there. Okay, so we can remove those NAs by detecting means we can remove those data using means with giving the condition. Suppose we want to give some condition like this for DF. Not equal to data should be only we'll see is dot NA. Suppose we want to give for both age and score, we are clearing the data. Any of the score, any of the values in that in those in the variables should not be include the NA1. Okay. So for that we are giving a AND condition where any of this those columns variable should not be include the NA variable. As we have mentioned earlier, also we have to keep some comma to complete those. Okay. Now you can see any text variable is not there. Only maybe outlier may be there. We need to clear, but there is no any or not available or blank is there in the data set. This way you can means first you have to clean the not available or missing cases. Then you have to, if outlier is there, uh, you have to clean the outliers. Like this condition I have given, the if the data should be less than 50 age variable. Similarly, you can give for this data also. This data should be maximum of suppose 66. Okay, you can only include those which are less than equal to 66. Above that, the data would be cleaned. Okay, similarly, so you have to mix the uh, for cleaning, you have to make use the both the logic. First, you have to see the outlier also. Also, you have to see the if there is any text or something is there. Okay, through this way you can clean the data. I hope means now it is little bit clear for you, so that how you can proceed for big data. Yeah,
So,
some ready. Yeah.
so when you remove the NA, does that mean they'll delete the entire row? Or like, how is it removed? What will happen to
No,
that?
no, no. They are cleaning only those with them giving some another values more than means the practical one. The outliers they're including. Okay. So you have to manually then you have to give a filtering like this one. I have given for DF clean should be less than 50. So you can for this one you can give less than suppose age should be less than 66. Okay. If you again do the DF clean, you will get the cleaning. Suppose I am giving here same thing. Okay. Now you can see the observation has reduced. If we check this DF clean, now you can see more than those observation we will remove those. First you have to check the outliers, then you can clean. Otherwise data would be missing. So for that I have created a new data so that my original data is not would not missing. Okay, means if you need again the original data, it should not be deleted. That's why I've created a new file named as df underscore clean. Is it fine for everyone?
So when we have a
Okay, go ahead, go ahead.
when we have a large data set, and if the data has like NA values already,
Mhm.
so do we remove it to replace those columns with some other values, or
If
like?
you see, if you have uh, the earlier days, someone was asking if in my column, suppose in a numeric column, there is some text or something is there. Okay, so first we have made, we have make those text file to non-numeric. Means non-numeric to numeric. We have made those. Okay, so they have made as a numeric some outlier values they are taking. Okay, so then you have to give the condition ki my value should be this up to this my value would take. Okay, so if you give that conditions like this, I have given for age, the age should be maximum of 66. Okay, so for that for more than 66 it will automatically remove and it will be saved as a new file, as I have done here for the new file as underscore df underscore clean. I have given the name. Okay, similarly you can give on your own, means it's up to you. Yeah, you're saying something.
Okay,
Um,
Saurabh, I have one question. Can we
Yes,
can we
yes.
save this like this variable if we'll clean and we can
Mhm.
create a new variable in the same data set?
Yes.
So it
You
will be
can create
better otherwise, huh? Mhm.
you can create a new one.
Okay.
Okay, I'll show
New
them.
means new data set or like
No,
new
new
variable?
variable in the, you can create a new one, new variable only.
Okay.
Okay, I'll show.
The same questions I was also wondering. Ki
Mhm.
like if we'll change, so will it clean all the means row or just that particular, and how I will identify that this is changed in which number? Like when
Okay,
we encode in
you can,
a state,
yes,
when we okay,
you
okay,
can see here in the environment only, the observation, if you can see, 2976 observation in our original data was there. Okay, after cleaning, it was there 2966. So 10 observation we have deleted based on our cleaning.
okay.
Okay. And regarding the column one, the last day when we making some data frame or data manipulation, I think we were creating some new uh, column. Okay. So that command is mutate only. Command is like this. We are creating a new column, creating new column like for DF only. Suppose we want to create from, we want to create, suppose uh, score percentage. Its score is there, I think here. Yeah, score is there. Suppose we want to create a score percentage out of score, like we do in Stata also. So we are giving the variable name as score percentage, and it will be calculated as score divided by 100, and okay, I have not called that library. Sorry for that. You have to first call the library because it was under the library dplyr. So you have to use the library also. Yeah, this way you can create. And I will also show means how you can do the decoding. This will only create here only, but it wouldn't be saved for in a new data in the data set only. If you check this one, it won't show that variable, but also key it will come in subsequent order key how to we can create that in our data set only. Okay, I have not shown that one. I just only have saved key. I have only created the column only, but we have not saved. I'll come to that one also. Okay. Is there any issue? This was some of the functions or some of the tricks we can use when we have a large data. If some missing cases or some text is there, or in the text column there is some numeric is there, we can identify those through the first we can check the structure of the data frame. Okay, if we check the structure, if the you can see now the age variable structure is now as numeric. Score is also numeric, but if you see income variable, we have not modified, so it is still it's as a character. Okay, we need to means clean that one also. So I'm not going that one. You can check on your own, but I'll go to some other other our courses course curriculum. So meanwhile, I'll come to create a new variable from the existing one so that it can be saved in the data also. So that your original variable would not be hampered. Okay. So I'll come that one. So maybe we can take just 5 minutes break. Then we can start the data hypothesis testing. It will take some time, 40-45 minutes. So request if you can take some 5 minutes break, then we can continue. Is it fine? Yeah. Meanwhile,
Sure.
please download all the. Thank you. Meanwhile, you can download the rest of the data which will be needed for the further this hypothesis testing one. Okay. Some data was student data is there, then pass fill data is there, then employees, some data is there. I hope every data set is been shared. If someone can confirm that one so that this T data set, I hope everyone got it. Student, employees, and pass fill data set. Okay. If you kindly quickly look into this so that we can start 5 minutes. Okay. Thank you. Yeah, yeah. So someone has asked if I want to see the entire row with NA values. Uh, Blank of text. Yeah. If it is blank or anything is there, it will automatically convert into numeric also in as numeric function we are using. Okay, then you can again convert those, means you can clean the data. Okay, and if you want to see the entire rows with NA values, how to do so? You can also, means after converting those NA file, you can again means if NA is there, so you can again change also. I have already shown that one. Maybe day two, if you see, you can check that one. I don't want to repeat that one. I can maybe later I can keep that code also in the code script. Okay, I'm not going there in that query. Okay, I'll give that code in our script. Maybe I should continue with the hypothesis testing because that would take some time. Okay, is it fine with everyone? Yeah. Did you everyone downloaded that three files, that students file, pass fail, and employees, so that we can run those? So we'll go again to our studio. I will clean this script for you later. Now I'm just going to hypothesis one. So first we'll want to read, suppose the student file, pass fail file, and employee file. Okay, together I will means three file will run one by one. For this data analysis, we need two of our package, that is dplyr and ggplot. So yesterday or the last season we have already installed those, so we'll just uh, all those libraries so that later we don't have to face any error message. Okay, so first just run those library, then we'll call those csv file. Suppose we want to give df underscore student. So for that, we'll run that file, that is students. Then again, we'll just copy this path. You can see the new data set has already came here. This is the data set. Okay. This is df student I have run. Similarly, you can do this for df baby pass file, that is df pass. I have given it name read.csv. You can also copy paste to save your time. Just have to keep the file proper file name. So it was as it is as pass fail data set, this one. Okay. Again, df underscore pass has also come. Okay. Now the third one, that is df underscore, suppose I am employee one. So again, just copy the same one. Just change the file name because the path is same. Only we have to change the file name. File name is employees. Okay. So if you run this one also, it will count. the df underscore employee. Okay, these three file we'll use today for various testing on all those things. You can also check those header, also head file, as we have already mentioned in the last class about how you can check the first few observation of the data set. So you just have to mention the file name. Suppose we want to check the student first few variables, means observation, sorry. So if you run those, it will automatically give in your console the first few observation of your data to the head. Okay. Now, suppose we want to do the t-test. Okay. T-test means t-test why we want to do. Suppose for this file, we want to check the mean of suppose male or female, group male or group female. What is there any difference in their mean? For that, we need to do the t-test. I hope the basic of t-test is already known to everyone. Okay, so if you want to check if is there any difference between the score of male and female, so for that we'll do the t-test. The function for that is t dot test. Then in bracket, we want to check the scores of it. We want to check the mean score of male female wise. So score and gender variable we'll use. Okay. So for that, we want to see the score. So we'll mention the score then with the gender. Okay. So then where we are taking from this, from which data we are taking, it is df underscore student. Okay, you can write like this, or you can mention the score variable like the dollars with the dollar sign, how we are using this one. You can write like that one also. It's up to you how you can mention. So that means data should come properly. If you just simply run this data, means it is function, it will automatically give the two sample t-tests, because here we have two sample of male and female wise observation of total I hope 500 the student is there. Their male female wise we are doing the is their mean score is different for male and female. So if we run that one, it will give the t-test result where t statistic is there. It shows the difference between the group mean related to variation. Then the degrees of freedom is there. Then the p-values, it is there. And our original hypothesis here is there is no mean difference between the group male and group female. Okay, and the alternative hypothesis is there is a difference. So this is showing the alternative hypothesis. Our group female and group male's difference is there. Okay, then it will give the confidence interval, that is -2 to 2.9, that is almost 3. Then it is showing the mean of the group male and group female. If you see the group male and group females score is almost similar. Okay, so it is, and also the p values, if you see, it is not less than 0.05. That is our standard rule. The p value should be less than 0.05, and if it is not there, and so there is no much difference between the two mean. And you can also see the confidence interval is too high, from -2 to almost 3. Okay, so as the p value also supports, also the confidence interval is too large, so we'll reject our original hypothesis that is there is much difference between the two. You can visually see through the mean also. Okay, so there is no much significant difference in the scores between the two gender. Okay, this was the first testing. T-test through T-test, we can check if there is a difference between the two groups. Okay. Then we can come to another test that is very much used, that is chi-square test. Okay. So chi-square test, for chi-square test, we should make the contingency table. Means suppose we want to check the someone is mentioning something. Okay. So suppose we want to check the pass fail scenario. If you see that df underscore pass file, there is a data on gender wise pass fail. Zero means not zero mean fail, one means pass. Okay. So I have made it binary so that it would be easier to calculate. So suppose we want to check the male female wise, is there any compare the counts of the pass and fail between the male and the female? Okay. So for that, we'll use the chi-square test. The formula for chi-square test is suppose we want to store that data. Suppose table, under the table is, because we have to make the contingency table, as you know, in the chi-square test. So we'll use store the data here in the table format. Table is it will make a table for table type data, okay, of the contingency table mainly. So for that we are using that df underscore pass file, this file. Okay, we'll select that one and we'll use the through the gender wise we want to check. First we will mention the gender variable, then we want to see the gender wise pass fail variable. So pass fail variable was there as pass, a variable name I have given as pass. So for that we can mention that variable as, this is the file name and the variable name is pass. Okay. So if you run that, it will generate a contingency table here, table underscore pass, table underscore gen pass. This would be the contingency table. Okay. So now if we want to the chi-square test, you have to write chi sq dot test. Okay. So we want to do the testing through this contingency table. They are making a 2 plus 2 table here, male female wise, and pass and fail. Okay. So that for that table we are calculating the chi-square. So then what we'll use the function chi sq dot test, and in bracket that table will mention. Okay. If you run that one, you can see the Pearson chi-square test. It is showing the result where the chi-square value is showing 6.79, and the degrees of freedom here is 1 because there is a total 4 observation, and means number a row -1 and column -1. If you do, it will give the degrees of freedom. Means the formula is column minus the column minus means row -1 and column -1 multiplication. Okay. So yeah. So if you again here see, you can see the p values is much 0.05, means p value is much lower than the original our means this p value is 0.009, which is much lesser than the p value of standard p value of 0.05, 95% confidence interval. So here the result showing there is a very much there is a strong association between the counts of male and female. That is our main original hypothesis. Against the alternative hypothesis, there is not much there is no strong association between the counts of the male and the counts of female of the pass variable. Okay, so it is showing there is gender affecting the pass fail in this data set. Okay, this way you can check if there is a binary variable is there for 2 cross 2 variable. You can see the chi-square test. Okay. View is not working anywhere in my code. No, I think there is some issue in your maybe R. You can close the R session and again on that one it will. Yes, maybe the coding is also some issue. Yeah, capital V. You should keep the capital V also, or otherwise, if there is some issue, you can restart the R. It will work. Okay. So this was the chi-square test. Then we can also see, we can compare also mean of salary of multiple different. If more than, suppose we are checking only for the two groups. If there is multiple group, it is there. If we want to check the mean of those, okay, how we can proceed? We can do the ANOVA, analysis of variance. Okay. So for that, suppose we can use this, the third data set which I have given, that is the employee data set, where it is there, department wise salary is there, expense is also there. Okay, you can use that one. Hello, is my voice is not clear? Okay. Okay, so for employee this data set, how you can proceed the ANOVA. So first, for that ANOVA function, we have to use the function is ANOVA. Suppose we want to keep the name of it, ANOVA, suppose employee wise I'm giving. So the code is AOV, analysis of variance. Then we want to take that, suppose this salary one we want to take as department wise we want to check. Okay, so these two variables, department and salary, we want to take, and we want to use this data underscore emp. So for that we have to mention the salary variable. You have to give the name properly, otherwise R is case sensitive, as I already mentioned. So there would be some error or correctly mention the variable name. So you are giving the two variables, salary and department. Then data you have to mention, you want to use the employee data. Okay. So if you run that one, okay, so it will keep that, it will run. Then for seeing this one, you can use a function called summary. Summary you have already seen. It will give the all the summary of that data. So if you run that file, it will give the analysis of variance for your means for that test. Okay, so you can see we want to check the department wise. There is 4 department, I think. So for that, DF is showing the 3. Okay, and if you can see, there is a summary square is there, mean square is there, and F statistics value is there. As you know, the ANOVA is the analysis of variance is the F test. Okay, so the F value, F statistics value, if you see, it is 0.682, and if you check the P value, it is much higher than the your original means your standard cutoff of 0.05. So if your hypothesis is like this, there is a much difference between there is no much difference between the salaries of the different department, but we are rejecting that hypothesis. The test is showing there is a much variance among the department salaries. Okay, because we are rejecting the null hypothesis. Okay, the probability of that value is showing much higher than the our standard cutoff of 0.05. Okay, this way you can check uh, different type of test for different data. I'm just giving some examples so that the process you can know, so that you can apply in your own data also. Okay. Similarly, you can also see the correlation and regression. I will come to the correlation first. Suppose I want to check that student data again. Suppose I want to check with age and score. I can export. I'll come. Will come to exporting the result. Don't worry. So if you want to check the students age and score wise, is there any correlation between student age and student score? Okay, so for that what we have to do, we have to write like correlation, we have to write COR. Okay, then you have to mention which data frame you are using, that is df underscore student we are using, which variable you want to check. First, the variable name is suppose age, sorry, capital H. Okay, comma. The second variable. The beauty of this R is like if you load multiple data set, you can check the correlation with the other data set also. But you have to see is it applicable? I mean, is it really reliable that result? That you have to check. Otherwise, it would be better to use in the same data set only. So suppose for this data set, we want to check the age with the students score. This variable score. Okay. Close the bracket. So now if you run, you can see the values is minus 0.01. Okay, so basically correlation, what correlation does the see that if there is a strong means measures the means really if, is there any linear relationship between the two variables. Okay, so how the strong measures the strangeness, basically which direction it is going. It can go either positive way or it can be to the negative way. The value can take from -1 to 1. Okay, so positive means increasing together, means if the age is increasing, the score is also increasing. Okay, and negative means if some age is increasing, score is decreasing, or score is increasing, age is increasing. That means the opposite direction. Okay, so here it is showing the minus 0.01. So it is going to the negative relationship, but the value is little bit almost near about 0. So it is not that much strong as strong relationship, but it is a negative, slightly negative, you can say. Okay, so age is not strongly related to score, but there is a relationship in a negative way. Okay, is it fine with everyone? Okay, this way you can see the correlation. Okay, now if you want to check the relation regression, linear regression, suppose we will start with linear regression. Suppose we want to check we want to see the association between the score and age. Here we are taking only 2-3 variable. Tomorrow only we can use a big data. We will use some data from the NFHS so that there would be many more variable would be there. So we for today only we are just giving the basic idea of regression. Okay, so suppose we want to see the same. We want to use the student data only. We want to check the same relation what we did done in correlation. The same thing we can do in the regression only. We want to predict if score is based on age only. So for that, we are again storing the result so that it can be exported. Like someone was asking how to export the result. Okay, we are storing the those results so that we can further we can export. Okay, so LM means linear we are doing. Okay, so linear regression, LM linear multiple regression actually, but we are doing here for two variable only. It can be taken as multiple variable also. We'll see later on. Suppose we want to see the same thing as we have seen in the uh, that correlation only, score and age. So we are taking the two variables, score and age. Then we are taking from which data, that is student data. Okay. So if we run that one, the data would be saved. And now if you want to see the result, similarly, again, we have to use the summary function. Summary in bracket, that data set is, and that name of that uh, file is lm underscore student, where we have stored the linear regression result. Okay, there is some issue, I think. Maybe I've mistakenly write something else. Okay, so now you can see this is the linear regression result. Okay, first it will give the residuals as summary does, the all the minimum, maximum, quantile wise each scenario and median. Okay, then it will. Is there any query? No. Okay. Okay, so if it is not there, so we can see the result, means minimum maximum. First we have to check, then we can see yeah, then the coefficient you can see, means first you have seen that residual part, then you can see the coefficient part, where our only variable is age and the intercept value is there, because the formula, as you know, between the if the two variable is y and x, if you say, then y equal to a plus bx, okay, same. Okay, so if you see the result, it is showing like age, the estimate coefficient is showing the negative one. So there is a opposite uh, opposite direction with relation between the two variables. Okay, with the age, maybe age increasing, the score is decreasing. Okay, so minus 0.446 means with the for each increase in the age, the score decreases by 0.046. Okay, on an average. And but result, if you see the value of the p-value, it is much higher than the that or our original cutoff, or you can say the standard one, 0.05. So we can reject that hypothesis. So the association is showing, but the result is not significant, statistically significant. Okay, so age has no effect on the scores, and this stars actually denotes with a significance. Means if there is a 3 star, that is 99.99, then it's 2 star, it's 2 star, and similarly 1 star. Similarly, you can see this thing we can show in the latter part also, in the when we do the logistic and all those things. We'll explain detailing. So this way you can do the normal linear regression. Okay, there is also some residual error, or R square value is also giving, which is R square values. You can see the almost 2 tends to 0 only. Okay, then the F statistic is also giving, which is also showing the same result of what t value or t statistic value is giving, which is the p value if you see, which is almost very much higher than the our cutoff 0.05. Okay. So R square basically this multiple R square or adjusted R square, you can see if it tends to 0, that means the model explains almost nothing about the variation in score. Okay, if it is more values is there, so then it can explain the variation among the score. Okay, so this was the linear regression part. Okay, so suppose now we want to see uh, uh, linear regression. Same thing can be applied, although that pass fail data was there na. So that thing in that data set also we can show that word, but the issue is that here the data, if you see the pass value is as a binary outcome it is giving for both among the device is pass fail is giving, so it is coming under the binomial uh, group of distribution. So we'll use the logistic one. Okay, logistic distribution. Logistic regression mainly. Yeah. Yeah, we'll see that those result into also in the last part. After showing all the tests, we'll see how to export the result in different file. Okay, latex file you have to see. Okay, I have to see actually how to export, but it can be done. I'll show in the txt file and excel file. Okay, for now, but I have to explore the latex file. I have not done in latex file. I'll see and let you know in the next class. Okay. Okay, so for doing the logistic, suppose we want to do for this data set df underscore pass. Okay, so first we have to, what we have to do, first we have to read that file. We have already read that file df underscore pass. Okay, so for that suppose logistic, we are giving this logistic model. Okay, I have given shortcut as block model. So for that we'll use the function glm. Okay, this is a generalized least square model. Okay, so for that we'll take the variable pass, because that was only the binary variable that we want to check the gender wise and make female wise. So we'll take the pass variable, sorry, the variable as pass, and we want to check with the age as well as gender. Now we are doing for multiple variable. Okay, this way you can give the multiple variable. For two variable, we are giving like this. Okay, for multiple variable, if you, this is your outcome variable. Okay, this is outcome variable. These are the independent variable. Okay, this way you can give. Then you have to keep the comma. Then you have to mention which data you are taking, or you can write like this, or you can write like this also. Okay, it's up to you, whatever you want to give, which way you can go. So then you can go to the that particular data set we have mentioned. Suppose here it is df underscore pass, which I have already mentioned. Then you have to mention the which family of the distribution of there is there, because we are doing the generalized least square models. So it is as binary because logistic deals with the binary value. Family is binomial. Okay. So if you run that, then if we can see that summary of that that result, which is log underscore model. you can see the result of logistic model. Okay. So similarly for the as we are showing in that linear regression, that was in using the t-test, but here it is using the z-test. Okay, and this were the values of z values, and this is the probability value. You can see the both the values are significant, and this uh, this star is signifies the statistical significance is there or not. As the values, this value is much lower than the 0.05, it is showing the more significant statistical significant. Okay, basically in 3 level we see it's 95% or 90% or 99%. So among the two star it's 90%. So uh, so we can see that gender male is more significant toward, but negatively significant with the our pass fail value. Okay, you can also mention here I am taking the male one. How to do? We can mention that I will show the later one, because we will take more of the categorical variable later. Okay, now it is male female only, so it is automatically taking the first category, the gender male. You can also select the female one, but I'll leave that. I'll keep that in your exercise so to explore. Tomorrow we'll try that one. No, CI, it will, the test will automatically calculate. We don't have to set. CI will give the result. Okay. So this was the logistic distribution, but if you want to, in logistic distribution, mainly we want to see also the odds ratio. Okay. For that, we have to go for a further step. We have to get the exponential value of the coefficient, as you all know, to calculate the odds of that odds ratio. So for that, we have to calculate exponential of that coefficient which we have calculated coefficient of that particular model, that is log model. Okay, so here we can compute the odds ratio of each three intercept, age and mean. You can save this one similarly for like I have done for this. So you can save this one also. It's up to you how you want to proceed. Okay, I have not saved it yet, but we can save it also. Okay, so what the result signifies here is age value is 0.05 and this p value is 0.02. So it is showing for each year increasing. Okay, the odds of passing is almost about here the almost 5% it is showing for the intercept, yeah, for here. But odds, you can see the through the odds you can also predict how the predictor is increases, or likelihood of passing that result with the gender you can also see. Okay, that is there, and it is also significant. Okay, so these are the process of how to proceed to compute the logistic distribution. Will come with the NFHS so that the result would be more significant, or it would be more easier to understand, means associations. Okay, this way you can see those testing, various type of testing you can see. There are many more tests is there, so you have to see the function mainly. So, but the concept how you can do the testing is this. Okay, now we come to that to how we can export the result. Okay, so suppose for that the function is sync, SINK. This is the function through which we can export to a text file or txt file. Okay, suppose we want to give a file name as model dot summaries dot txt. Okay, this file we want to create, and we want to store the result from whatever we have done up to now. Suppose we want to store the result of this LM students we have calculated, then you can again also want to store like LM EMP also we have calculated, or we can also store the log model just we done. Then you have to write sync and you have to do like this. So see, it will automatically output will be stored in a text file which will include all the result from this model. If you want only one result, you can write only one. I want every result, so I will write every summary. Okay. Okay, EMP was not there. Maybe EMP has not, we have not taken. So exclude that one. These two we have done. So we can run, it will be run, and it will be saved in your working directory which you have mentioned. So we have mentioned in, suppose this file we have mentioned. So here you can see the model summaries file. This txt file is there. If you open that one, you can see all the result from starting from that LM underscore students, then log model, it will continue. Okay, this way you can save to a txt file, but you can also export in a Excel also. Okay, so for that, what we have to do, we have to export like this, right? As we have exported in Excel also, write dot XLSX. Suppose we want to log model only, we have want to export. Okay, the file name you can give that logistic notes XLSX. But it is showing error because we have not called that library. On the first day, if you can remember, we have to call the library for exporting. That was library EXL. Okay, so first we have to call that library to run. We have called that library. I hope it's not running. It's has been done. Okay, let me check once. Once, just check. Okay, for that, sorry, that was Open Excel. Yeah. For that, we have to Excel export. We have to run the Open Excel. Okay. So again, I have written the same thing, the log model, those things, and similarly, I have stored the log dot or. Okay, that is odds ratio, and we have calculated the uh, odds ratio, and then sorry, file name. I believe because it was a counting model. Yeah. So what it was doing, like this mod for this tidy function, I have used to calculate the odds ratio. You can calculate the odds ratio using the exponential function also. But if you want to this way, you can also calculate the exponential of to calculate the odds ratio. If you want to store something, you have to give some function, or you can use the same exponential also. But here I have given the tidy model there to calculate the odds ratio. Okay, so tidy of log model, that the same model and exponential and this true has to be true, then it will calculate the odds ratio of it. Okay, so if you compute that one, and then same thing, this function or the same file name, if you put in into in your exporting, then you can get the this logistic XLS file. This way it will say with the odds ratio, standard error, Z value, year file. You can also include, if you can calculate the CIs, I'll see if you can compute the similar thing with the CIs. Okay, I'll give an exercise where you can, if you can calculate the CIs, so that we can also include that CIs in the file. I'll see if someone can calculate. Okay, otherwise I will help, but we'll first try to calculate those if you can export through this. Okay, I will stop here today. I was running out of time, and we are yet to finish. Also, you can also plotting is also I have not completed today, but we'll see. We can start with this one only, this testing one only. The last one maybe 5-10 minutes it will take to see how we can show the plotting also. Similarly, what we have done in using the ggplot only, we can show with this data also. Maybe for this big data it will be interesting to see. Okay, I'll stop here. Maybe tomorrow we can start with the plotting here. So maybe some in the scatter plot we can include smoothing, we can include to give a regression line, or box plot we can also show different type of, or histogram. Then we can go to the NFHS data with some research question we can include, and then we'll explore how to do that, means how to proceed with that. Okay, is it fine with everyone? If you want to export TTS table and chi-square, can you do the same? Yes, yes, yes. Similarly, you can do, means you can give a file name, okay, to where it is storing, then it can be similarly exported. Okay, you can try that one. If you face any issue, means you just have to store that result to somewhere so that it can be exported. Okay, is there any other query?
Sir, I might have missed this. Just asking once again. If we want to, let's say, run multiple regression models in a same table, then
Mhm.
how do we do that with like age plus gender plus something if we add new variable.
Yes,
then-
yes. If your variable is, there is 4 5 variable, if you want to check multiple regression, you can do like adding plus plus plus. Okay, we'll explore that one with that NFSS data tomorrow. Okay. Meanwhile, you can see up to now, I'll give the script by tomorrow morning maybe. Okay, you can check those that this testing this codes. Okay, so that we can proceed with the NFSS data. Is it fine?
Yes, yes.
Yeah. Okay, so I think that's all for today. Uh, Tomorrow we can meet with the same time and we'll do the NFSS.